All right, so in this one, we're going to go over, this video, we're going over the beginning of the 1.2b notes. We're going to start with calculating with scientific notation, okay? So in the last video, the last set of notes, we introduced scientific notation. We want to be able to use scientific notation to perform calculations with these exceptionally large or exceptionally small numbers. The reason that's important is because your calculator has limitations. You can't enter 1.697 times 10 to the 22nd on your calculator and then multiply it by another exceptionally large number because the calculator just won't let you do it. It doesn't have enough memory there. It doesn't have enough places on the screen to get you to the large numbers. Okay, some of the graphing calculators, the larger numbers you use will spit out answers that are in scientific notation, but we still want to be able to use operations to perform these calculations, okay? So given these three values, okay, A, B, and C, these are all approximations. We want to calculate the product of AB divided by C, okay? So first thing we want to do is we want to make sure all the numbers are in scientific notation. So A, we want to convert to 4.6 times 10 to the negative 4, okay? Remember, if we're moving the decimal to the right, our exponent will be negative, okay, when we're going from decimal form to scientific form, okay? So let's plug the three values in. All right, so we've got A, which is the value we just came up with, times B, 1.697 times 10 to the 22nd, divided by C, 2.91 times 10 to the negative 18th, okay? Again, these are all approximations, so I'm going to keep that approximation symbol in front. So in the numerator, what I want to do, I'm going to multiply 4.6 times 1.697. Okay. We learned the laws of exponents recently. Remember this 10 to the negative 4, this 10 to the 22nd. I can add those exponents, okay? So my numerator is going to be the product of 4.6 and 1.697 times 10 to the 18th power, okay? And my denominator won't change, okay? So 4.6 times 1.697 is 7.8062. And again, we said times 10 to the 18th, okay? So now I'm going to divide these two expressions. All right, so I'm going to divide 7.8062 by 2.91. Remember the laws of exponents. I'm going to subtract these exponents, 18 minus a negative 18, which becomes 36. So my answer then will be approximately 2.6825 times 10 to the 36th power. Okay? All right, so pause the video here. Try B on your own. Notice that the expression here is a little different than we started with in part A. So we're going to do B times C over A, okay? Try your best on that, then come back and check your work. Okay, so A, we want to write that in scientific notation, 8.4 times 10 to the negative 4, okay? Let's plug in the values that we know. So B times C divided by A, okay? Just like above, we can multiply 2.195 times 6.81, and we're going to add these exponents, 21 plus a negative 19. Okay, so that's going to be times 10 to the second power. All right. When I multiply 2.195 times 6.81, I get 14.94795. Okay, times 10 to the second. Okay, notice this numerator is not considered to be in scientific notation, but I'm not going to convert it because I want my answer to be in scientific notation. I know if I divide this number by 8.4, I'm going to end up with a value between 1 and 10, okay? If I were to change this, it's going to add steps, because then in my next step, I'm going to have another value that's not in scientific notation, so I would have to convert that also, all right? So try to look and make sure you're making the right decision so you can be efficient with your steps, okay? So I'm going to divide 14.948 just about by 8.4. I'm going to subtract these exponents, 2 minus a negative 4, and I get an answer of 1.7795 times 10 to the 6th, okay? So that's how you use scientific notation with operations, multiplication, division, and so on, okay?